Hi and welcome. This time around we're taking a look at deburring and countersinking tools. And the reason I've got them both in the same video is because every one of these tools can be used to deburr, but not every one of these tools can be used for countersinking. So you've got the traditional deburring tools like the Shaviv ripoff here and an actual one, a real Shaviv deburring tool. This one's designed for plastics. These are one set, but all of these other countersinking tools can also be used to deburr. I've got a couple unusual ones here. This is an external for a pipe or round part deburring tool, as is this one right here. This supposedly does inside and outside at the same exact time for deburring. Those are kind of interesting. And you can always use a large drill bit to deburr as well, often by hand. I've done that many a time. So this is a 3/4 inch drill bit. Just get in there. This is 118 degree flanks on this, and use this to remove the swarf off the edge of your drill holes. All these other bits were designed for countersinking, but of course they'll also remove the swarf. This one is one of my favorites. This bit Tom Lipton recommended. This came from McMaster-Carr. It's actually $50 for this hex bit. It's made in Germany and it absolutely works fantastically. I don't know if there's any ID on it. 2.05 high-speed steel. I use this to deburr round holes all the time. This thing is still really sharp considering I use it non-stop. This set is another hex shank set I found on Amazon. I don't like this style as much. The ones with lots of flutes, I find they chatter, but I got it to test out, and they're hex shanks, so that made it convenient. All of these other ones are drill bit mounts, or drill mounted. This is a handheld hex mount one. This one also is a decent high-speed one from Germany as well. So that's also a really high quality. All these other bits are countersinking bits of different angles. And you're wondering why I have so many? Well, because I could never figure out which ones were best number one, and I kept my eye open on eBay for sets that were like new open box. And I got really good deals on them. This one I recently bought from MSC, only because the style is very much like this one, and I thought maybe it'd be better. These are spiral 3-fluted, and I was hoping these guys would do a good job. I use this kind quite often. This is the round kind that you basically press in and has one cutting edge, single flute. That's pretty effective. I find that these multi-flute ones, nowhere near as effective. This is 6 flutes. Now, there's different angles for these because these countersinking bits are designed for different screws. So in the US, we use 82 degree flathead screws. Metric are 90 degrees, so that's the difference there. This is 60 degree. This is designed for both countersinking and removing of burrs or reaming. So if you want to make a hole chamfered at 90 degrees, or 60 degrees rather, this is the way to go. And this Weldon set here, this also is an interesting way. This is called a 0 flute because they just got a hole drilled through it. They're easy to sharpen because you can get a file through here, although they're pretty hard, so that doesn't always work. Maybe a diamond file would work. I haven't had to resharpen any yet. I've got this old style here and some bigger examples of it. This one is big enough that even on my lathe, I get nothing but chatter out of this. And this is brand new, was brand new when I first started using it. I have never gotten a good countersunk hole from this guy, or even a good deburring. This is Morse, so this is a good big brand. Also, center drills can also be used to move to deburr parts and countersink. This is a 60 degree countersink right here, built into the center drill. So those can also be handy. This one also is another multi-flute design. This is 6 flutes with a carbide head, very sharp. I have never been able to use this without chattering either. To organize most of this crap, especially all these individual sets, I 3D printed a part real quick. Just to hold them, it'll take a lot less space, and I can fit all these on here. So I'm going to load this up, and then why don't we head over to the mill and see if we can see a difference between these various countersinking solutions and or deburring solutions. I'm going to drill a bunch of holes. leave some burrs, and then come back and see if we can remove them. Maybe we'll be able to find out which bit is best. I honestly don't know. Like I said, my favorite so far is this one. Usually does a good job. I do get a little bit of chatter on this guy. With these, I get a ton of chatter. These are pretty decent. They take a lot of force. They may not work on everything. I'm hoping these will be the magic bullet, so we'll give those a shot. As you can see, I can fit all the bits in here. I can get to most of them pretty easily. Some of them require a little fiddling because I made them kind of tight, but it got rid of all these individual holders, which is going to free up a lot of space in my toolkit. And for me, space is everything because I don't have enough room at all. With everything else I brought out, I missed this set of deburring tools. These are 3 different sizes, and they're designed so you push this in and it lines this part up so that you can stick it through a small hole, and then when you release it, you can either release it this way or this way, like this. Come back and deburr the back side of a hole this way. Probably easier to see with the big one. So straighten it out, stick it in the hole, pop it back out, pull, and deburr the back side of the hole. They actually work really well, especially for blind holes that go into a blind pocket that you can't get into. So these are really handy to have. All right, so I got a piece of stainless loaded up here. It was one of the worst materials I could think of that's readily available for throwing a nasty burr that you want to remove. Stainless is really gummy, and so the burrs often are tenacious and like to really stick there, and they just sort of move around rather than are easily removed. Worst material would be Inconel, but you know, a piece of Inconel 1/8 inch thick this size would have been a fortune, so we're not going to use Inconel, and besides I don't have any. And if I bought it, it would probably be hundreds of dollars for this little piece. So we won't be doing that, but we will be trying to deburr this guy, and we're going to drill a bunch of 1/4 inch holes in it. You can reduce the burr on the backside where most of the burr ends up by easing up on the drill pressure as it starts to break through. That's not always easy to do, but it's pretty effective when you're able to do it. So that's something to keep in mind. I got to get myself a center line here so that I can flip this part over when I'm done and get to the back of it, because we're going to want to deburr the backside because that's where most of the burrs are going to be. We're going to use some anchor lube, and I just need to do a little metrology here, find the center line here so that we can easily get back. Whoa, that worked hard and like crazy, didn't it? That took out my drill bit like a bad habit. Huh, I looked up RPM for 1/4 inch drill bit and it should be like 3,000. I'm running at 1,000, but that's acting like it's way too fast because that just totally cooked that bit. Wow, this is hard on drill bits. Wow, look at that. Cooked another drill bit. That's amazing. I think I need carbide for this. Just welds a bunch of stainless on the end there. Boy, hadn't run across this before. Maybe even slower still, I don't know. That's insane. Gonna leave the speed the same, 700 RPM. This is a solid carbide drill bit. It's a little bigger. No problem there. All right, it gives us 12 holes. Should be enough. Carbide went through it very neatly. Boy, high-speed steel, did not like it. I think I would have tried cobalt next, but I had this Goering 7-point-something millimeter drill bit that's bigger, but I think we need the carbide. So I tend to run the countersinks in slow speed. So I've got the back gear in. We're at 200 RPM. And I guess we'll start with the one that always chatters. And we've got the top side here, which has really relatively minor burrs. So Well, today it's actually working pretty good. Usually, this is the first time I've ever not had this one chatter on me. All right, let's try one of these round ones. These do take a fair amount of force. People speak really highly of these. It mostly smeared material. Like this one, there's no burr on the edge. This one, there is a burr on the edge. Let's see if I go more gently. Nope. This is, by the way, a brand new bit, never used. All right, let's try next one over. This is a 60-degree, very sharp point. That also lifted a burr up. Now the ones I have the least success with. That was really good. Maybe this type works better on stainless. That's an interesting question because that worked really well. Here's the Goering one. This one's the best one so far. This is the second best. Both of these are no good in particular. And if you're wondering which bits they were, this was the first one, second one, third one, fourth one. We're now on the Goering one for number 5. Oh, that one's fantastic. That's a pretty small hole. We're going to go over the next size up. We'll do 2 in a row for the Goering one. Very low tool pressure, beautiful finish, no burr. That's fantastic. Next up, we're going to choose one. That last one was the Goering one right there. Now we're going to choose the single flute version. That worked okay, not bad. Larger hole. These require a lot more force, these single flute ones, but they're not turning up a burr either. They're pretty good. Also, I forgot to mention, this is a standard center drill, 60-degree chamfer on the edges. They also have center drills with radiused edges. You can buy these from McMaster as well. If you're using this to drill a center on the lathe, it gives you a big advantage over these just because the curve gets things out of the way. All right, so here's using a center drill as a deburring tool. Pretty good result. Took a lot of force. And last but not least, we're going to try a standard drill bit because that's what you can use if you have nothing else. That removes material quickly, tends to bounce all over the place, but works. All right, here's what we have so far. There's that 6 flute over here. There is the single flute, turned up a nice burr there, that's no good. The 90-degree 3 flute also turned up a burr. The finish isn't bad. The 90-degree 6 flute did a better job, no burr. Here's the Goering bits, they did a fantastic job. Here is the 1 flute, so the Goering did a fantastic job. The single flute did a pretty darn good job as well. Took a lot more pressure though. There's a center drill, and the last one is a drill bit. And you can see that that one's not terribly even. It's got some thin and some wide spots. All right, so now we're gonna flip this guy over where the big burrs are. And every one of these has a nasty burr on it. So we're gonna shoot these do these next. All right, here's a 6 flute carbide. Kind of a nasty burr. And a boatload of chatter on that side. Yeah, once the chatter's there, you can't make it go away. That's what the experience I've had with this in the past. It worked pretty well on the normal screw hole, but not so well where there was a big burr sticking out. All right, next up, we're going to do the round one here on number 2. Takes a fair amount of force, leaves a bit of a burr that your fingernail can feel, but it did remove it. That did an okay job. Left a little bit of a burr though as well. Now the ones that I have a really bad luck with, a 6-flute non-carbide. Better luck than the solid carbide one, no burr. That actually worked reasonably well. All right, so next up is the Goering. We're gonna do 2 spots, small and a big hole. This one's got a terrible burr. No problem. Just pushed a little harder to remove the material. Easy peasy. Took that off like butter. This should have lined up straight, but I'm feeling like we're a little offset, which is my fault. All right, now the round one. This is going to be challenging. We're going to go for a bigger one. Yeah, it worked. I've had good luck with the round ones. No problem there. No burr turned up, no burr turned up. Last 2 will be center drill. All right, center drill. That worked. Bit of chatter there. Last but not least, drill bit. That works fine. It just doesn't do a very even job. Got high spots and low spots on it, but it does remove the burr pretty quickly. So in a pinch, definitely works. For the last 2 holes, even at an angle here, I'm going to try this with my trusty German-made one from McMaster Car, and this one does a great job. No burr. That one is very similar to the Goering one here. All right, so here's what we have. On the back side, where the big chunks of metal were sticking out because of blowing through with the drill bit, got a 6-flute carbide here. Chattered like crazy. And once it started, you couldn't stop it. The 0-flute did an okay job, but turned up a burr like it did on the other side. Same with the other side here. I'll go back to that in a second. 3-flute 60 degrees also turned up a burr, so these kind of suck. I'm not a big fan of these guys here. 6-flute 60 degrees. This guy did an okay job. Cleaned up nicely, didn't chatter too much, didn't turn up a burr. The Goering, these guys right here, were by far the best, tied with the one I got from McMaster Car here, the German-made one. Fantastic deburring bits. Nice clean holes, no burr turned up. Single flute did a decent job, but took a lot more force pressing down to clean up. Center drill did an okay job, but left some metal burrs. The drill bit did an uneven hole, but did work. And there's the McMaster, which also did a fantastic job. On the front side, where there wasn't much of a burr, the 6-flute did a great job. I've never seen it do a great job before, so that was impressive. So when it doesn't have a bunch of metal to move out of the way, this one did an okay job. The single, or the 0-flute, that's the 0-flute. The 0-flute did not a great job on this side, turned up a burr on both sides. 90-degree 3-flute, this one again, did a decent job. I'm sorry, this one here, that turned up a burr. That did not do a decent job. 90-degree 6-flute did a decent job. That one actually worked. The Goering did a great job on both the small and the large hole. The one flute did a great job on the small and large hole, but again, took a lot more force. Center drill did an okay job, turned up a little bit of a burr. Drill bit did a very uneven hole, and I didn't do this side with the McMaster, but that's pretty fantastic. That's my go-to tool. So there you go. You got a bunch of different styles, and this new design by Goering seems to be the best for at least my setup and stainless steel. You know, this could change with different materials. Like some materials probably cut really easily and it doesn't matter. So all these will work fine, but on stainless, definitely some better than others. And maybe things change. Maybe these sharp ones here will do a better job on something like aluminum or brass, something soft. I don't know, you have to try all the materials over time. But that should give you a little bit of a head start. I found it interesting. Hopefully you find it useful. Thanks for watching. Hope you find it useful. Hope to see you next time.